Hello, DevOps and SRE aspirants. Thank you for joining us on our Pro DevOps Journey channel to become DevOps and SRE aspirants. In the previous video, I discussed the duties of development and operations teams. In this video, I will discuss the responsibilities of DevOps engineer. Let's see the agenda of this video. I will start by explaining who is DevOps engineer, and then I will go over DevOps principles. Then we will look at the DevOps engineer's responsibilities. Finally, I will wrap up this video by talking about the tech stack of DevOps engineer. Let's find out who the DevOps engineer is. A DevOps engineer implements methods, tools, and strategies to balance needs across the whole software development lifecycle, from coding and development to maintenance and upgrades. He is someone who knows the software development lifecycle and is well versed in the numerous automation tools used to build CI/CD pipelines. And also, a DevOps engineer collaborates with developers and the IT operations engineer to manage releases. He is interested in systems engineering and network operations. DevOps engineers are either developers who are interested in system engineering and network operations, or system admins who are interested in scripting and coding and have migrated over to the development side to optimize test preparation and deployment. They also enjoy automating manual jobs using their scripting and coding abilities. Let's talk about DevOps principles now. One of the important cultural characteristics of DevOps is increased communication and collaboration in certain organizations. As we know that developers focus to write code and transfer it across the world. Operations experts are concerned with tools, compliance, and the cloud, and the security team wants to ensure code is secure. So they all may not have the same priorities or speak the same language. As a result, communication and collaboration is one of the key principles that a DevOps engineer must adhere to release the software first to the market. Next, continuous integration. It is a software development practice where developers regularly merge their code changes into a central repository, following which automated builds and tests are run. Continuous integration main goals are to detect and fix defects faster, increase software quality, and shorten the time it takes to validate and distribute new software upgrades. And next, continuous delivery. It is a process by which code updates are automatically built, tested, and prepared for production release. It extends continuous integration by delivering all code changes to both the testing and production environments. Then, next DevOps principle is continuous testing. It uses automated tests to ensure teams receive immediate feedback to quickly reduce as many as risks as possible during the development lifecycle. Next, continuous monitoring. Organizers analyze metrics and logs to see how application and infrastructure performance affects end user experience. By capturing, categorizing, and then analyzing data and logs generated by applications and infrastructure, organizations understand how changes or updates impact users, providing helpful information or knowledge into the root causes of problems or expected changes. As services must be available 24 hours a day, 7 days a week, and the frequency of application and infrastructure updates grows, continuous monitoring becomes increasingly vital. And then infrastructure as a code. The notion of infrastructure as a code states that infrastructure should be provisioned and controlled using code and software development practices such as version control and continuous integration. Because they are defined by code, infrastructure and servers can quickly be deployed using standardized patterns, updated with latest patches and versions, or duplicated in repeatable ways. Finally, continuous improvement. It is critical to the success of any DevOps environment. This requires extensive testing and monitoring. Regular testing allows you to detect current process flaws and rectify them while offering feedback on progress. Now, let me go over the responsibilities of a DevOps engineer in this slide. DevOps engineer assists developers, quality assurance engineers, and performance engineers with build and deployment issues. Using Groovy scripted and declarative pipelines, he creates Dev, QA, and performance CI/CD Jenkins pipelines. He ensures that these pipelines are working smoothly and without any problems. DevOps engineers manage source code and adhere to a versioning approach for each release. DevOps engineers freeze the code before the release date to avoid problems caused by unexpected changes. In addition, he creates new branches and respective jobs to perform CI/CD for each release. After the release, they will do post-production tasks such as unlocking code freeze, deleting old branches and Jenkins jobs, and closing change requests. They guarantee that all projects adhere to organizational guidelines. They also run code scans to ensure the quality and security of each update. DevOps engineers write automation scripts for configuration management, infrastructure provisioning, and deployment automation. They administer servers by patching and upgrading them. They write Docker files to containerize the applications. DevOps engineers continuously monitor application health and assist developers in retrieving error logs from logging tools. They work on initiatives like migrations, remediations, patches, and the integration of tools to automate the CI/CD process. Now I will talk about the tech stack of a DevOps engineer. Whatever the applications we use regularly, like Facebook, Instagram, and YouTube, are placed on operating systems like Linux and Windows. So, DevOps engineers should have knowledge on operating systems like Linux and Windows to manage the servers. DevOps engineers should automate the manual tasks whenever they are working on Linux or Windows servers. So, they use scripting languages like Groovy, Shell, and Python to automate the manual tasks. Every tool that DevOps engineers use is API based, so it requires expertise in XML, JSON, and YAML files. DevOps engineers should have Agile knowledge, so to manage the projects in Agile, they use Jira. They should document and store knowledge items of each issue or process, so they use Confluence to document the process. Developers or DevOps engineers manage their code, scripts, and configuration on central repository, so they use Git for source code management. After coding or scripting, developers or DevOps engineers should compile and package the code. So to automate this process, DevOps engineers or developers use build automation tools like Maven. After compilation and packaging, artifacts will be generated. So to store these binaries, DevOps engineers or developers use JFrog Artifactory so that they can easily move the binaries to different environments. To orchestrate, build, test, and release the software to multiple environments, they use continuous integration and orchestration tool like Jenkins. DevOps engineers use SonarQube for code quality checks and finding bugs of the code. They use Nexus IQ for dependency scan. DevOps engineers use Ansible for configuration and deployment automation. They use Docker for containerization. For container orchestration and management, they use Kubernetes. To automate the infrastructure provisioning, they use Terraform. To manage cloud native applications, they use AWS Cloud. And DevOps engineers use Splunk, Dynatrace, Grafana, and Prometheus for logging and continuous monitoring. That's it for this video, guys. We will discuss DevOps CI/CD process, site reliability engineering, and roadmap to become DevOps professional in upcoming videos. Please subscribe, like, and comment, and click on the bell icon to get notifications on upcoming videos. Thank you and see you again. Please feel free to mail me if you need any assistance to become DevOps and SRE professionals.